Good afternoon, YouTube. Here we are looking at the web interface on my Vera home automation controller. So these three devices here are my AOTech home energy monitor, that's the HEM. So this home energy monitor has two current clamps, one on line 1 and one on line 2. So line 1 right now is using 205 watts, and on line 2 I'm actually pushing 177 watts in, and that gives me a net power consumption in the house of 32 watts. This is what I call Diversion Load 2, and it's a 600 watt heat lamp setup with a light dimmer. And then down here, I've also got a similar 600 watt light dimmer load on line 1. Of course, it's not doing anything because there's excess load on line 1, but there's excess power on line 2. So I'm having to use up that excess power, about 120 watts worth. And if we go over here, this is my Home Assistant interface, and I'm looking at the Grafana graphing package here. The blue is line 2. You can see down there the legend line 2. Yellow is line 1, and then green is the total power. But one thing to look at here, if we just zoom in on this short section, you can see the way the excess power coming in on line 2, you can see how it has this gradual slope to it. Starts out quickly and then it gradually tapers down, and here's the green is the whole house power. It jumped up and then it's gradually coming down. What was going on here, you can see the yellow line jumped up, so I went from about 215 watts up to 332. So that was probably the refrigerator turning on, so the house started using power. But I was burning up excess power on line 2 with the diversion load. So gradually over a minute or so, I ramped the diversion load down to let more power feed into the house, and you can see how the house went from 187 watts down to 25 watts down here. And then what happened at this point, I have my freezer directly AC powered off of the solar power inverter. The freezer turned on, and so now instead of being able to pump 290 watts of power in, so right here I'm limited and I can't quite drive the house power down to 0. I'm down to like 120 watts. And then probably what happened right here is the refrigerator turned off. You can see the yellow, and now the house power dropped down to like 9 watts, and now it's stabilizing here again at about 25 watts. And what we can do here is look at the way this is working. So this is my program logic event generator. So this is a program that I'm running, and if we come in here, I made a few little changes, and one of the things I did was I tried to clean up my code a little bit. So I have a number of functions that operate on line 2, and then down below there's the exact same set of code that all work on diversion load 1. I moved all of these conditional expressions around so that they occur in order. So the first thing that happens in the morning is I start up the diversion load. So anytime the power drops down below 1 watt, this starts up in the morning, and it pretty much runs until the end of the day, sunset. This is kind of the real meat of the system, this load 2 increment. I just compute what kind of change do I want to make in the dimmer. I take the target power, I subtract off the current power, and if there's a difference, I divide that by how many watts per step on the light dimmer, and that's about 6 watts per step. And so you can see right here it's telling me that I should be at 47% on the dimmer. Then I have this function here called load share, which says if there's excess load on line 1, use the excess load to gobble up the excess power. So it's saying I want to burn up 47.5% of the diversion load, but 46.9% can be used by the rest of the house. I'm computing a new setting here based on the current diversion load setting, and then I add the increment, and then the load share, and then the load assist, and all that math comes up with 3.7. Instead of 47%, I only need 3.7% on the dimmer. So then this next function here, this is one of the things I did to clean up the code a little bit. With the Lua programming environment that you use on the Vera, the program logic event generator uses a subset of Lua, and that's what this code is. One of the restrictions that I think applies is you can only have one line of code. You can't have a semicolon and 3 more lines of code, or parentheses and have a function. You get one line to write your code. And then the other thing is there's no temporary variables per se. So what I have here, this is what's called a conditional expression. So I say take the current setting, and if it's less than 0, I set it to 0. If it's greater than 100, I set it to 100, and then otherwise I just use the value. The dimmer device doesn't like to see 110% setting. It doesn't know what to do with that. So instead of computing this 3 times in a row, I just compute it once and assign it to a conditional variable. In the next conditional expression, I reference that conditional variable, and I don't have to compute it again. So that saves a little bit of computation. The thing I changed to get that damping factor, this is my damped setting. If the current setting is less than the new setting, which means I'm going, say, from 50 watts of load up to 100 watts, I want to just do that, do a step function. But if the new setting is less than the current setting, I take the current setting plus the new setting and divide that sum by 2. So for instance, if the diversion load were at 100 and I wanted to go down to 50, take 100 plus 50, divide that by 2, and the damp setting would be 75. And then that just repeats. The next time around, I would be at 75. I want to go to 50, and it would come out 62. And then it would be 62 plus 50, so you'd go down to 56. And then you'd go to 53, and then 51, and finally you would end up at 50. So that's how I'm getting this tapering off that you see in the graph there. It might take a minute or so to get down to a new steady state. Yeah, that's really helped out quite a bit. I used to every once in a while get into a case where the system would just oscillate between like plus 100, minus 100, plus 100, minus 100. It would gradually zero in, but it would go plus and minus for several minutes. Because one of the problems is, if we zoom in here, all of these dots are individual samples. In between, I don't know what's going on, and I can only do things every 15 seconds. When did the load come on in that cycle? Did it come on a second after I took the reading, or a second before I took the power reading? There's no way to know what's going on in the house, because the refrigerator turns on and off by itself. The freezer turns on and off by itself. So that really helped. Adding that damping function in there really helps with these step function changes. And for example, I have one person make a suggestion that I shouldn't be doing things on that short of a time schedule. You should be sampling the overall trend and trying to anticipate what's going to happen. Well, how do you anticipate 1,000-watt jumps up and down that happen totally at random? I guess what you would have to do is have smart power reporting switches on the dishwasher, the refrigerator, every light switch in the house. Everything would have a reporting function, and then you could feed all that data in and say, oh, the dishwasher turned on. But that would be so expensive to outfit your whole house, every single device with a power reporting meter, and then have that all report back to your hub and then be able to compute all those numbers. Yeah, it'd be great if you could do that, but you would spend thousands of dollars on all of that infrastructure to save 20-30 cents a day in power. That would be a real overkill. So pretty much I've set the code up to respond to changes. Seems to follow pretty good. You get that 1 or 2 cycle blip that might get some negative power here, but I've got it down to where it's less than 30 watt hours per day that this goes negative. 15 seconds is 1/240th of an hour. So if it went to 240 watts negative for 15 seconds, that's 1 watt hour. I don't think you can do a whole lot better unless you had a full grid zero type of hybrid inverter, which I don't have, but this is pretty close to it. But anyway, I wanted to show you the updated system. Everything seems to be working pretty well. It's very stable now, and it's trying to use as much of the excess power that I have productively, and then anything that's left over gets thrown away. And here's where I had the hybrid inverter turned off, and you can see if I turn that off, I get nothing extra. If I turn it on, all the area between 0 and the blue line is energy that I've recovered. So here, it's got about 200 watts for an hour and a half. So that's 300 watt hours there that I've recovered. And yeah, over the course of a day, this can recover maybe 2 kilowatt hours off of the hybrid system and just reduce my energy bill by a couple of kilowatt hours a day. But yeah, if you have any questions about that, post up in the comments section below. I'll put a link to the videos where I initially set this up so you can see a little more how the whole system works if you want to see those details. And as always, thanks for watching.